Hello there, and welcome to the Sleepy Science Channel. Tonight, we're going to drift into the powerful, mysterious, and sometimes terrifying world of natural disasters. Earthquakes, storms, volcanoes, and floods. These forces have shaped the surface of our planet for millions of years. They are fierce, unpredictable, and often destructive, but when viewed from a place of safety, they become something else entirely. Awe-inspiring reminders of how alive and dynamic our Earth truly is. Each disaster has a story to tell. An earthquake can make the ground ripple like waves upon the ocean. A volcano can paint the skies with colors unseen in ordinary sunsets. Storms can summon winds so powerful they bend landscapes, and tsunamis can carry the pulse of a single wave across entire oceans. These events are not just destructive, they are also creators, carving valleys, building mountains, and even giving birth to new islands. If you enjoy these gentle journeys, I invite you to like and subscribe, or share a thought down in the comments. It helps others find their way here too, one sleepy soul at a time. But for now, all you need to do is relax. Allow yourself to sink into comfort as we embark on this epic journey into the hidden power of the Earth. Let's begin. Earthquakes can make rivers flow backward. Most of the time, rivers follow the pull of gravity, carving their way downhill and out to sea. But in the rare moments when an enormous earthquake strikes, the very flow of a river can be reversed. During the Great Quake that shook Alaska in the 1960s, entire sections of rivers suddenly surged upstream for minutes at a time. The ground moved so violently and so quickly that it tilted the riverbeds, sending water rushing in the opposite direction. People watching saw waves running backward against the current, as though time itself had briefly reversed. The same phenomenon has been recorded in the Mississippi River, where earthquakes centuries ago pushed its waters to flow north instead of south. These moments are fleeting, but they remind us that Earth itself is not fixed. It is flexible, restless, and alive, strong enough to bend the natural order we take for granted. The largest earthquake ever measured shifted the entire Earth's axis. In May of 1960, the largest earthquake ever recorded struck Chile. It is remembered as the Great Chilean Earthquake, and it reached a magnitude of around 9.5 on the Richter scale, the most powerful quake in human history. The shaking was so intense, so widespread, that it did more than collapse buildings and create tsunamis. It actually altered the planet itself. Scientists studying the event found that the redistribution of Earth's mass caused the axis of the planet, the invisible line around which the Earth spins, to shift by several inches. Even more astonishing, the quake shortened the length of a day by tiny fractions of a second, because the planet's rotation had subtly changed. It is a reminder that natural disasters are not only local events. At their most extreme, they can ripple outward until they touch the very balance of our spinning world. Some earthquakes make the ground roll like waves on the ocean. We often imagine earthquakes as sudden jolts, a violent shaking that rattles windows and topples walls. But some of the strongest quakes are stranger, more surreal. Instead of a quick shake, they make the Earth move in slow, undulating waves. During large earthquakes, particularly those that stretch along faults for hundreds of miles, the ground can behave like liquid. Roads ripple as though they were cloth. Buildings rise and fall in rhythm with invisible swells. People standing on open fields describe feeling seasick as the land beneath them heaves up and down. This is not imagination. It is the elegy of seismic waves traveling through solid rock, bending and flexing it just like water. For a few unforgettable moments, the Earth feels less like solid ground and more like an ocean in motion, reminding us that beneath our feet the crust is flexible, responsive, and full of hidden movement. Lightning can strike the same place hundreds of times during a storm. There is an old saying that lightning never strikes the same place twice, but nature does not follow our sayings. In fact, lightning often strikes the same location repeatedly, especially if that place sticks out above its surroundings. The Empire State Building in New York City, for example, is struck by lightning dozens of times each year. In some storms, a single tower, mountain peak, or radio antenna may be struck hundreds of times in succession as storm clouds continually discharge their energy into the tallest, most conductive object available. One of the most extraordinary natural displays of this is the Catatumbo lightning in Venezuela, where storms gather at the mouth of a river and unleash strikes night after night, sometimes for hours at a stretch. Far from being random, lightning is drawn to certain paths, carving a glowing fingerprint of energy across the same patch of sky, again and again. Volcanic eruptions can create their own weather systems. When a volcano erupts with immense force, it does more than pour out lava. The ash, heat, and gases thrown into the sky can disturb the atmosphere so profoundly that they create entire weather systems above the eruption. Massive columns of ash rise tens of thousands of feet, where moisture condenses into storm clouds. Within these churning towers, winds swirl, raindrops form, and lightning flashes in chaotic bursts. Scientists have recorded volcanic plumes generating thunderstorms that rage directly above the crater. In some cases, these volcanic storms even develop their own miniature tornadoes, spinning out of the billowing ash. It is as though the Earth is creating a storm within a storm, a violent fusion of fire and air. These volcanic weather systems are short-lived, but they show us the raw connection between Earth's surface and its skies, where fire can call down thunder and ash can summon lightning. There are storms on Earth that spin faster than a jet engine. The most powerful storms on our planet are not just massive, they are also unimaginably fast. In certain supercells, enormous thunderclouds that give birth to the strongest tornadoes, winds can spin at speeds faster than the blades of a jet engine. Some tornadoes have been clocked at well over 200 miles per hour, tearing houses from their foundations and flinging heavy vehicles into the air like toys. The energy contained in such storms is beyond human scale. Scientists who chase them describe watching funnels twist with such speed that their edges blur, like the spinning of a colossal drill. At their most extreme, the rotation is so rapid that air pressure inside the funnel plummets, and the surrounding atmosphere rushes in with explosive force. To witness such a storm is to see the atmosphere itself unleashed, spinning with the furious mechanical precision of nature's own engine. Tsunamis can travel across entire oceans without losing much power. Most waves fade as they spread out, their energy weakening with distance. Tsunamis are different. Born from massive shifts in the seafloor, earthquakes, landslides, or volcanic eruptions, they are not just surface waves. They are waves of the entire ocean, carrying energy through the full depth of the water. Because of this, they can cross entire oceans with only a slight loss of strength. After the great earthquake off the coast of Japan in 2011, waves raced across the Pacific Ocean, striking distant shores hours later. In the 19th century, a tsunami triggered by a volcanic eruption in Indonesia traveled more than half the globe, its waves still strong enough to be measured on the far side of the world. Tsunamis remind us that the ocean is connected everywhere, and that one violent pulse in its depths can be felt by continents an ocean away. Some tornadoes have tossed trains off their tracks. We tend to think of tornadoes as capable of damaging houses or uprooting trees, but some of the most powerful twisters are strong enough to hurl objects we usually imagine as immovable. In the American Midwest, Eyewitnesses and historical records describe tornadoes lifting entire trains, dozens of connected cars of steel, and throwing them from their tracks. Locomotives weighing hundreds of tons have been shifted by winds compressed into a narrow funnel. The mechanics are brutal yet fascinating. The winds do not simply push the train, they create a low-pressure vortex that can lift heavy objects upward, much like an enormous vacuum. Photographs after such storms show twisted rails and scattered train cars lying in fields like discarded toys. These accounts give us perspective on the raw physics of tornadoes, rotating winds so strong that they can tear even the heaviest machines of human industry from the earth. Earthquakes can trigger volcanoes thousands of miles away. The Earth's crust is a web of plates, fractures, and stress lines, all interconnected in ways we are only beginning to understand. When a massive earthquake strikes, it does not only rattle the land near its epicenter. Seismic waves travel outward, pulsing through the planet's interior. In rare cases, these waves reach dormant volcanoes and stir them awake. After enormous earthquakes in Alaska and Chile, scientists noticed a sudden increase in volcanic activity thousands of miles away. The vibrations loosened magma chambers, disturbed delicate balances of gas and pressure, and in some cases even set off eruptions. It is as if the planet itself shudders in sympathy, one violent event rippling into another across vast distances. These connections remind us that the Earth is not a collection of isolated features, but a single living system, where one disaster may whisper to another, sparking a chain reaction across the globe. Hurricanes release more energy than all the world's nuclear weapons combined. A hurricane may look like a swirl of clouds from space, but hidden in that swirl is energy on a staggering scale. As warm ocean water evaporates and rises, it fuels an engine of condensation and wind. The amount of heat released by a single hurricane in one day can rival the entire global arsenal of nuclear weapons, detonating at once. Scientists estimate that the total power output of an average hurricane equals hundreds of trillions of watts, more than all the electricity humans produce worldwide. The winds themselves are only part of it. The real energy lies in the latent heat of water vapor condensing into rain. In effect, hurricanes are colossal machines powered by the ocean, converting heat into motion and destruction. When we look at their spirals on satellite images, we are seeing not just weather, but one of nature's most powerful engines unleashed. A single lightning bolt can heat the air hotter than the surface of the sun. When lightning flashes across the sky, the brilliance is so sudden and intense that it seems impossible to grasp what is happening. A single bolt is a channel of electricity racing between cloud and ground, discharging with unimaginable force. Inside that channel, the temperature surges to over 50,000 degrees Fahrenheit, many times hotter than the surface of the sun. This heat instantly superheats the air around it, causing it to expand in a violent shockwave. That shockwave is what we hear as thunder, rolling outward like the crack of a cosmic whip. For a moment, the air becomes a furnace hot enough to melt sand into glass, leaving behind strange, branching structures called fulgurites buried in the ground. To witness lightning is to see nature's raw electricity unleashed, transforming the sky into a glowing, thunderous theater of fire, hotter than the very heart of our star. Supervolcanoes have erupted with the force to change global climate. Most volcanoes are dangerous but localized. A supervolcano, however, is something entirely different. These rare giants do not merely spew lava and ash over a mountain slope, they release enough material to blanket continents. One of the most famous examples lies beneath Yellowstone National Park in the United States. When it last erupted hundreds of thousands of years ago, it hurled so much ash into the sky that it altered global weather patterns. Supervolcano eruptions can dim sunlight across the planet for years, cooling temperatures and devastating agriculture. Geological records show that past eruptions have caused mass extinctions, wiping out entire ecosystems. The sheer scale is almost beyond imagination. Thousands of cubic miles of rock and ash blasted skyward in an instant. Thankfully, supervolcano eruptions are incredibly rare, separated by hundreds of thousands of years. But their lingering scars remind us of the unimaginable power hidden beneath our feet. The deadliest cyclone ever recorded claimed over 500,000 lives. In the year 1970, the Great Bhola Cyclone struck what is now Bangladesh and parts of India, unleashing winds, rain, and a storm surge that overwhelmed entire coastlines. The storm surge, a massive wall of water pushed ashore by the winds, inundated villages and farmland, sweeping away people, animals, and homes in a matter of hours. Communication and emergency infrastructure were limited at the time, and the densely populated lowlands had little protection. In the storm's aftermath, the death toll reached staggering heights. Estimates range from 300,000 to over 500,000 lives lost, making it the deadliest tropical cyclone in human history. Beyond its human toll, the disaster also reshaped political landscapes, fueling movements that would later lead to the birth of a new nation. This single storm was not only a meteorological event, but also a pivotal turning point in history, carved by wind and water. A dust storm once carried soil all the way across the Atlantic Ocean. We often think of dust storms as local events, coombs of sand rising in deserts, coating towns and cars. But Earth's atmosphere can carry far more than we realize. In the Sahara Desert, storms sometimes lift billions of tons of fine particles high into the air. Winds then ferry this dust thousands of miles across the Atlantic Ocean. Satellites have captured immense plumes drifting from Africa all the way to the Americas, a reddish-brown haze that spans continents. The dust falls on the Amazon rainforest, carrying nutrients that help fertilize its vast ecosystems. In this way, a desert on one side of the planet directly nourishes a jungle on the other. But these same storms can also cause air quality problems, dim skies, and disrupt weather patterns across the ocean. What seems like a simple dust storm is actually a global scale exchange, linking distant ecosystems with invisible threads of wind. Some volcanoes erupt underwater, building entire new islands. Most of Earth's volcanoes do not rise above the sea. They are hidden beneath the waves. Along the ocean floor, molten rock constantly erupts, creating mountains and ridges that we rarely see. Sometimes these submarine eruptions are so powerful that they breach the surface, piling lava and ash until a brand new island is born. In 2015, an eruption in the South Pacific produced an island that scientists first thought would crumble quickly, but instead it persisted and became a home for seabirds. Other examples dot the Pacific Ring of Fire, where islands are still rising from the ocean. Some of these newborn islands last for only a few years before waves erode them back beneath the surface, while others become permanent fixtures on maps. These hidden eruptions remind us that the Earth is still building itself, one fiery island at a time, even in the quiet seas. Fire whirls are real tornadoes made of flame. Imagine a tornado spinning violently across a field. Now replace its swirling dust with fire. That is a fire whirl, a rare but terrifying natural phenomenon. They form when intense heat from a wildfire creates rising air currents that begin to spin. The flames and embers are sucked into the vortex, transforming it into a flaming tornado that can climb hundreds of feet into the air. In 2018, during massive California wildfires, observers recorded fire whirls strong enough to toss vehicles and uproot power poles. In Japan, during the Second World War, a fire whirl born from bombing raids turned city blocks into infernos. Though short-lived, These fiery twisters are among the most dangerous expressions of wildfire, spreading flames rapidly across landscapes and generating winds as strong as any tornado. They are nature's reminder that fire, when combined with wind, can become something otherworldly and terrifyingly alive. Earthquakes can turn solid ground into liquid. When seismic waves pass through certain kinds of soil, strange things can happen. Instead of shaking like solid rock, the ground may suddenly lose its strength and behave like a liquid. This phenomenon, called liquefaction, has been seen in many major earthquakes. In the 1964 Niigata earthquake in Japan, buildings sank and tilted as the soil beneath them gave way. Cars floated to the surface as though they were in water. The reason lies in the way vibrations increase water pressure between soil particles, forcing them apart until they can no longer support weight. Entire neighborhoods can slump and slide, not because the land cracked, but because it briefly turned fluid. Liquefaction is a reminder that the earth beneath our feet is not as solid as it seems. With enough force, the ground itself can melt into a shifting, unstable sea of soil and water. Avalanches can move faster than a speeding car. On snowy mountains, beauty and danger exist side by side. A peaceful slope can, in an instant, transform into a roaring avalanche. When layers of snow break free, they can accelerate downhill with terrifying speed, sometimes faster than 100 miles per hour. That is quicker than a speeding car on a highway. These cascades carry thousands of tons of snow, ice, and debris, uprooting trees and burying anything in their path. The physics is stark. Gravity pulls the mass downward, and as it slides, friction melts part of the snow into a lubricating layer of water, making the avalanche even faster. Skiers who have seen one describe it as a living wall of white, swallowing entire valleys in minutes. Avalanches are breathtaking in their power, sculpting mountain landscapes and reminding us that beneath the stillness of winter lies one of nature's swiftest and most unstoppable forces. Some tsunamis tower higher than skyscrapers. Most tsunamis reach heights of only a few feet in deep water, but under certain conditions, they can become towering walls that dwarf anything humans have ever built. In 1958, an earthquake in Alaska triggered a landslide into Lituya Bay, creating a wave that reached over 1,700 feet high. That is taller than most skyscrapers, and the tallest wave ever recorded on Earth. Trees were ripped from mountaintops, entire slopes were scoured bare, and the bay itself was transformed in moments. While such mega tsunamis are rare, they reveal the extremes that nature can reach when immense forces combine. Most tsunamis are devastating enough at only tens of feet high, but imagining one taller than a mountain ridge is almost beyond comprehension. These waves carry not just water, but the raw energy of gravity and geology, unleashed in one of the planet's most violent spectacles. The deadliest earthquake in history struck China in the 15th century. In the year 1556, the province of Shaanxi in China was struck by what remains the deadliest earthquake in recorded history. Though estimates of its magnitude place it around 8, the destruction it caused was amplified by the way people lived at the time. Many communities built their homes in Loess's caves, dwellings carved into soft, silty soil. When the ground shook, entire villages collapsed in an instant, burying families inside. Historical records described mountains crumbling, rivers changing course, and over 800,000 lives lost. The scale of human tragedy was unparalleled, and for centuries it stood as a warning in Chinese history. Unlike modern quakes measured with seismographs, the Shaanxi earthquake is remembered through chronicles and stories passed down. It shows us that even before modern cities and skyscrapers, the Earth had the power to devastate entire civilizations with a single, merciless shudder. Volcanic ash can ground entire fleets of aircraft. Volcanic eruptions do not only affect the land around them, they can also shut down the skies. When ash is blasted high into the atmosphere, it can drift for thousands of miles, carried by winds that spread it across entire continents. For aircraft, this is a nightmare. The ash is not soft like dust. It is made of sharp, glassy particles that can melt inside jet engines and cause catastrophic failures. In 2010, the eruption of Eyjafjallajökull in Iceland released an ash cloud that drifted over Europe. Air traffic controllers grounded thousands of flights, stranding millions of passengers and halting international travel for days. The sight of empty skies was eerie, a reminder that even modern aviation is helpless before the raw output of a volcano. One eruption on a remote island was enough to silence the hum of aircraft across an entire continent. Some hurricanes last for weeks without weakening. We often picture storms as fleeting, but some hurricanes are stubborn, enduring for weeks as they drift across oceans. Fueled by the constant supply of warm water, these systems can maintain their strength as long as conditions remain favorable. In 2016, Hurricane Matthew lasted for nearly 2 weeks, carving a path of destruction across the Caribbean and the southeastern United States. Other storms, such as Hurricane John in the Pacific, have lasted even longer, traveling thousands of miles before finally dissipating. These long-lived hurricanes demonstrate the persistence of nature's machinery. Once set in motion, they can sustain themselves for extraordinary stretches of time. They remind us that a storm is not a single moment but a living engine, powered by heat, moisture, and motion, circling endlessly until something disrupts its rhythm. A hurricane that refuses to fade is a haunting force of endurance. Ice storms can snap power lines like twigs. When warm air rides over a layer of freezing ground air, rain falls but freezes upon contact with every surface. This is the recipe for an ice storm, one of the most beautiful and destructive weather events on Earth. Trees become coated in glassy layers of ice, glittering like crystal forests. But the weight is crushing. Branches snap under the strain, and power lines sag and break as though they were no stronger than twine. In severe storms, entire regions can be left without electricity, plunged into freezing darkness for days or weeks. Roads become skating rinks, cars entombed in ice shells. The beauty of these storms hides their danger, for the weight of frozen rain is merciless. A single inch of ice can add hundreds of pounds to a single tree limb. What looks like a frozen wonderland is, in truth, nature's crushing grip of cold. Earthquakes can trigger massive landslides that reshape mountains. In mountainous regions, earthquakes often do more than shake the ground. They can loosen entire slopes, sending millions of tons of rock crashing downward. These landslides can dam rivers, bury valleys, and even create new lakes. One dramatic example occurred in Peru in 1970, when an earthquake dislodged part of Mount Huascarán, creating an avalanche of rock and ice that buried towns and killed tens of thousands in moments. Landslides triggered by quakes can permanently alter landscapes, removing entire ridges or carving new canyons. Satellite images taken before and after such events often reveal dramatic scars, visible reminders that a single moment of shaking can undo what took millions of years to build. Earthquakes are sudden, but their after-effects linger in the land itself, written into mountainsides as deep scars that will shape rivers, valleys, and human history for centuries to come. Tsunamis move so fast, they outrun commercial jets. In the deep ocean, tsunami waves are not towering walls of water. Instead, they are long, low swells, stretching for hundreds of miles. But their speed is astonishing. Driven by the full depth of the ocean, they can travel at over 500 miles per hour, faster than a commercial jet flying at cruising speed. Ships in open waters often barely notice as a tsunami passes beneath them, but as the wave nears shore, it slows and grows taller, transforming into the devastating walls we know from history. This combination of stealth and speed makes tsunamis so dangerous. Hours after an earthquake, a wave can strike a distant coastline with little warning. They are among the few natural disasters that move as quickly as human-made machines, reminding us that in the contest of speed, even our fastest creations cannot always keep ahead of the ocean's restless power. Megadroughts can last for centuries. Most of us think of droughts as seasonal, a year or two of dry conditions, ending when rains return. But history tells a darker story. In the American Southwest, evidence from tree rings and lake sediments reveals that so-called megadroughts have struck in the past, lasting not years but centuries. These prolonged dry periods reshaped entire civilizations, forcing ancient peoples to abandon cities and migrate in search of water. In Africa too, megadroughts have been linked to the collapse of kingdoms and the spread of famine. Such events remind us that water cycles are not always steady. Sometimes the sky is close for generations, and entire landscapes change as rivers shrink and forests die. Today, as climate patterns shift, scientists warn that new megadroughts could return. They are a reminder that time in nature is vast, and even something as life-giving as rain can vanish for centuries. Tornadoes can strip the bark off trees. The strongest tornadoes are so violent that they do not simply uproot trees or snap their branches. They strip them bare, tearing away leaves, twigs, and even bark. After the passage of such storms, landscapes look surreal. Entire forests reduced to ghostly stands of pale trunks, standing like skeletons. This happens because winds inside the funnel reach such high speeds that they drive debris, dirt, gravel, even small objects, against trees at bullet-like velocities. The abrasive bombardment scours away bark, leaving smooth, scarred wood behind. Meteorologists use these eerie signs to judge the strength of tornadoes, as bark stripping is evidence of the very highest wind speeds on Earth. For survivors, the sight is unforgettable. Once living trees transformed into pale, lifeless poles. In the silence after the storm, the stripped trees stand as haunting monuments to the fury of spinning air. Volcanic lightning looks like fireworks from the underworld. During a volcanic eruption, as ash and gas billow skyward, another strange spectacle often appears, lightning flashing within the dark plume. Known as volcanic lightning, these discharges form when particles of ash rub against one another, building static electricity until it explodes in sparks of light. The result is a sky filled with glowing veins of electricity, illuminating the eruption in a furious display. From a distance, it can look like fireworks from the underworld, fire and lightning unleashed together. One of the most famous examples occurred during the eruption of Mount Sakurajima in Japan, where lightning arced continuously through clouds of ash. These displays are mesmerizing but also dangerous, striking the ground miles away from the crater. Volcanic lightning is nature's reminder that when Earth's fire meets air, the result is not just eruption, but a storm of its own, dazzling and terrifying in equal measure. The largest hailstone ever found was bigger than a volleyball. Hailstones begin as small ice pellets inside thunderclouds, tossed upward again and again by strong updrafts. Each time, a new layer of water freezes onto the growing stone. Most hailstones remain small, but in rare storms, updrafts are so strong that the stones grow to monstrous sizes. In 2010, in South Dakota, a hailstone was discovered that measured over 8 inches across, larger than a volleyball and weighing almost 2 pounds. It left a crater in the ground where it fell. Such massive hailstones are rare but possible whenever a storm is powerful enough to keep lifting a stone higher and higher, allowing it to gather layers of ice until gravity finally wins. When these icy boulders fall, they can shatter windshields, punch through roofs, and devastate crops. They remind us that even something as ordinary as rain can, under the right conditions, become monstrous. Earthquakes can shift an entire coastline overnight. Earthquakes are not only violent in the moment, they can also leave permanent marks on the land. During the Great Chilean Earthquake of 1960, entire stretches of coastline rose by several feet in a single night. Beaches appeared where none had existed before, while elsewhere land sank, swallowing villages and fields. In Alaska's 1964 quake, parts of the coast dropped by several feet, creating new tidal flats that remain today. These shifts happen because earthquakes release pent-up stress along faults, sometimes forcing huge blocks of earth upward or downward. The changes can be so dramatic that old maps become instantly outdated, replaced by a coastline reshaped in hours. To imagine the land you know shifting overnight is disorienting, but it is a reality of living on a restless planet. Earthquakes are not only moments of chaos, they are also architects of Earth's ever-changing shorelines. Hurricanes can push walls of water taller than buildings. One of the most destructive features of a hurricane is not the wind, but the surge. As the swirling storm approaches shore, its powerful winds push vast amounts of seawater ahead of it, piling it higher and higher until it becomes a moving wall. In severe cases, storm surges have reached heights taller than multi-story buildings. The water crashes inland, flooding streets and sweeping away everything in its path: cars, homes, and entire neighborhoods. Unlike regular waves that retreat quickly, a storm surge is a sustained rise in sea level, often lasting for hours. People who have seen it describe it as the ocean simply rising up to claim the land. These walls of water reshape coastlines, erase beaches, and leave behind salt-soaked ruins. When satellites show a hurricane's broad spiral, hidden inside that image is a rolling mountain of water, capable of rewriting entire landscapes in one sweep. Some wildfires burn underground for decades. When we picture wildfires, we imagine flames racing across treetops and hillsides, consuming everything in sight. But some fires retreat underground, smoldering in peat, coal seams, or dense layers of organic soil. These hidden fires can burn slowly for decades, invisible on the surface except for thin plumes of smoke. One of the most famous examples is in Centralia, Pennsylvania, where a coal mine fire ignited in the 1960s and still burns today. In other parts of the world, peat fires in Siberia and Indonesia release massive amounts of smoke year after year. Unlike ordinary fires, these underground blazes are almost impossible to extinguish because they spread below ground where water and firefighters cannot reach. They can survive even through winters, reigniting surface vegetation when conditions warm. Silent, stubborn, and enduring, underground wildfires are reminders that once fire takes hold, it can smolder quietly for generations, reshaping air and land alike. Volcanic eruptions once plunged the world into a mini ice age. In the early 19th century, the eruption of Mount Tambora in Indonesia unleashed so much ash and gas into the atmosphere that it dimmed sunlight around the world. The year following the eruption, 1815, became known as the year without a summer. Crops failed in Europe and North America, famine spread, and temperatures dropped drastically. The sky was often hazy and sunsets glowed with strange, vivid colors because of the particles suspended high above. Entire regions endured snow and frost in months that should have been warm. This global cooling was not caused by ice, but by volcanic aerosols reflecting sunlight back into space. History remembers the suffering it caused, but it also demonstrates the vast reach of a single eruption. When a volcano of sufficient size erupts, its influence does not stop at mountainsides or coastlines. It stretches upward, wrapping the entire planet in a shadow of ash. Earthquakes can trigger rogue waves in the ocean. Rogue waves are sudden, towering walls of water that appear without warning, rising twice as high as the surrounding sea. For centuries, they were considered sailors' tales, but today, science confirms they are real. While most rogue waves are caused by the chaotic mixing of ocean swells, earthquakes can also set them off. When a quake shifts the sea floor, it can send out pulses that interfere with existing waves, building a sudden monster wave in the open ocean. These waves can rise as tall as multi-story buildings, slamming into ships with destructive force. Mariners caught in them described the sea as if it suddenly stood up, lifting their vessel on a wall of water before crashing down into valleys below. Earthquakes are already dangerous on land, but at sea, their influence can create these unpredictable giants, reminders that even in deep waters, the Earth's tremors reach upward. Tornado winds can drive straws through solid wood. In the aftermath of the strongest tornadoes, investigators sometimes find scenes that seem impossible. One of the strangest is the discovery of ordinary straws, the kind used for drinking, driven straight into telephone poles or wooden planks. The winds inside these storms accelerate debris to such high speeds that even something as fragile as a straw can become a deadly projectile. Under extreme pressure, the straw does not bend or break. Instead, it pierces wood like a nail shot from a gun. Scientists believe the tornado's low pressure may soften the wood fibers, making them easier to penetrate, though the full mechanics are still studied. To stand in the path of such winds is unimaginable, as the very air becomes filled with weapons of chance. These bizarre details are haunting evidence of the raw and unpredictable violence of tornadoes, where even the gentlest objects are transformed into instruments of destruction. Some floods have carried entire houses miles away. When rivers burst their banks, the force of floodwaters can be overwhelming. In the most severe floods, whole houses have been torn from their foundations and swept downstream like pieces of driftwood. Eyewitness accounts tell of buildings floating past bridges, tilting as they collide with trees and debris, sometimes traveling miles before breaking apart. Floodwaters are not just water. They are a churning mix of mud, rocks, cars, and anything else caught in the torrent. The power behind them is measured in tons of pressure per square foot, strong enough to collapse walls and snap beams. The survivors, the sight of a neighbor's home drifting by, is both surreal and devastating. These moments reveal that floods are not gentle rises in water, but rushing forces with the strength of bulldozers, capable of lifting entire structures and carrying them away as though they were made of paper. Earthquakes can create instant lakes. When the ground shifts during a powerful earthquake, the landscape itself can be rearranged. Rivers are blocked, valleys are dammed, and depressions open where none existed before. In these moments, lakes can appear almost overnight. After the Sichuan earthquake in China in 2008, entire valleys filled with water as landslides blocked rivers, forming dozens of new lakes. Some of them grew large enough to swallow villages, while others became permanent additions to the map. The sudden creation of these lakes often poses secondary dangers, as unstable natural dams can collapse and unleash flash floods downstream. Yet they also reshape the environment, creating new habitats for birds, fish, and plants. To witness a brand new lake after an earthquake is to see Earth resculpting itself in real time, turning solid ground into a watery basin as easily as if it were molding clay. Hurricanes can spawn dozens of tornadoes. As if the winds and rains of a hurricane were not enough, these monstrous storms often give birth to something even more chaotic: tornadoes. When a hurricane makes landfall, the turbulence along its outer edges can spin up dozens of smaller funnels, each with destructive power of its own. These tornadoes are usually weaker than those spawned by supercell storms, but their sheer number makes them devastating. During Hurricane Ivan in 2004, more than 100 tornadoes were recorded across the southeastern United States. Survivors often describe the eerie feeling of surviving the hurricane itself, only to face sudden tornado sirens afterward. It is a reminder that hurricanes are not just single storms, but vast systems filled with smaller storms nested within them. Like a fractal of chaos, they create destruction on multiple scales, from broad storm surges to the narrow spinning funnels of tornadoes. Tsunamis can cause Earth's rotation to slow down. The mass of our planet is enormous, but even it can be nudged by great movements of water and rock. When a giant tsunami is triggered by an earthquake, trillions of tons of water surge across the ocean. This redistribution of mass has a measurable effect on Earth's rotation. After the 2004 Indian Ocean earthquake and tsunami, scientists detected a slight slowing of Earth's spin, changing the length of the day by fractions of a second. Though imperceptible to daily life, it was a reminder that the planet itself responds to the shifting of its surface and seas. These changes are small but real, cumulative ripples of massive disasters affecting the rhythm of the globe. Tsunamis are not only local tragedies, but planetary events, altering the balance of motion in the very world beneath our feet. The loudest sound ever heard was a volcanic eruption. In August of 1883, the eruption of Krakatoa in Indonesia produced a sound so loud it circled the globe. Sailors hundreds of miles away had their eardrums burst, and barometers around the world recorded the shockwave passing again and again for days. The explosion was estimated to be over 10,000 times more powerful than a hydrogen bomb. Islanders close to the eruption described the sound as the sky itself cracking open, followed by a wall of noise so overwhelming it defied description. Even in far-off continents, people heard the muffled echoes of Krakatoa's fury. It remains the loudest sound ever reliably documented, a thunderclap of Earth's power that carried around the entire planet. The sound itself became a disaster, deafening those who heard it and etching itself into history as a reminder that when the Earth truly roars, the whole world listens. A volcano in Alaska erupted for nearly 3 years straight. Most volcanic eruptions last for days or weeks, but some linger far longer, producing constant activity that reshapes landscapes. In the early 20th century, the volcano Mount Pavlov in Alaska erupted almost continuously for nearly 3 years. Streams of lava and ash poured from its vent, creating a near-constant spectacle of fire and smoke. For the remote communities nearby, it became a background presence, a mountain that never seemed to rest. Such prolonged eruptions are rare, but not unheard of. Some volcanoes can simmer with activity for decades, releasing magma in steady pulses. These long-lived eruptions remind us that volcanic activity is not always sudden and explosive. Sometimes it is drawn out, a slow burn of the Earth's interior pressing outward in a relentless flow. To live in sight of such a mountain is to be constantly reminded of Earth's simmering heart. Some earthquakes are so silent, they can only be detected by instruments. Not all earthquakes arrive with jolts and shakes. Some creep silently, shifting the land so gradually that humans do not feel a thing. Known as slow-slip earthquakes, these events unfold over days or even weeks, releasing seismic energy without the sudden shocks we usually associate with quakes. Instruments detect them as steady, creeping movements along faults. Though gentle, they are not harmless. Scientists believe slow slip quakes can sometimes trigger more violent earthquakes nearby by redistributing stress. These silent earthquakes are invisible to the senses, but they remind us that Earth's tectonic plates are constantly in motion, grinding against each other in ways that are sometimes violent, sometimes subtle. Beneath our feet, a hidden drama plays out all the time, and even when we feel nothing, the planet is shifting and reshaping itself with quiet persistence. Fire tornadoes can lift burning debris thousands of feet high. In the most extreme wildfires, flames and winds combine to create vortices that resemble tornadoes of fire. These fire tornadoes are towering columns of flame and smoke that spin with terrifying force, sometimes reaching thousands of feet into the sky. In California's Car Fire of 2018, one such fire tornado grew as tall as a skyscraper, with winds estimated at over 100 miles per hour. It uprooted trees, flipped vehicles, and hurled burning debris across neighborhoods. Witnesses described it as a whirling tower of fire, alive with sparks and roaring like a jet engine. Fire tornadoes are among the rarest and most dangerous fire phenomena, capable of spreading flames across vast distances in minutes. They show us how, when fire and weather collide, the results can be something that feels almost otherworldly, a living inferno spun into the shape of a storm. Tsunamis can bend around islands and strike from unexpected directions. Waves usually cast shadows, obstacles block them, and sheltered places remain calm. But tsunamis behave differently. Because their wavelengths are so long, they can diffract around islands and headlands, wrapping around obstacles and striking shores thought to be safe. After the 2004 Indian Ocean tsunami, some beaches shielded by large islands were devastated because the waves bent around the barriers. This unusual property makes tsunamis difficult to predict and escape. Unlike ordinary waves that break against a cliff, a tsunami can arrive from multiple directions, colliding with itself in complex patterns. For people awaiting the wave, the result can be confusing and deadly. It is a reminder that tsunamis are not ordinary water waves, but deep, planet-spanning pulses of energy that obey their own rules, bending around the world until they find a place to release their strength. Floodwaters can move with the force of bulldozers. When floodwaters surge, they carry enormous amounts of energy. Just 6 inches of moving water can knock a person off their feet, and 2 feet can sweep away a car. Multiply this power across entire rivers, and the results are staggering. Engineers compare the force of floodwaters to bulldozers, pushing walls, vehicles, and bridges out of the way. Unlike machines, however, floods push everywhere at once, pressing against every surface with relentless power. People who survive flash floods often describe the sound of grinding rocks and trees crashing together, the water roaring with unstoppable fury. The debris it carries only adds to its destructive force, battering everything in its path. To see a flood in motion is to realize water is not just a gentle necessity of life. It is also one of nature's most efficient engines of destruction, capable of tearing apart landscapes with terrifying ease. Earthquakes can trigger geysers to erupt far away. Earthquakes do not always leave their mark only at the epicenter. In regions with geothermal activity, the vibrations of a quake can ripple through underground water systems, disturbing delicate balances of heat and pressure. Geysers that usually erupt on a predictable schedule can suddenly explode out of turn, shooting boiling water into the sky. After major earthquakes in California and Alaska, geysers in Yellowstone National Park erupted unexpectedly, some remaining restless for days afterward. The seismic waves traveled through the crust, stirring the hidden reservoirs beneath the park. It is a striking example of how interconnected Earth's systems are. A quake in one region can whisper to boiling water miles away, coaxing it upward in plumes of steam. These distant responses remind us that the Earth is a single, resonant body, where even a tremor in one place can cause water and fire to stir in another. Some landslides travel faster than race cars. When slopes collapse, they sometimes do so with a speed and violence that defies imagination. Landslides can accelerate downhill at more than 200 miles per hour, faster than many race cars. The reason lies in the immense weight of rock and soil, combined with lubricating factors like rainwater or ice that reduce friction. As the mass barrels downward, it gathers momentum, smashing through forests and valleys. Survivors describe the sound as a deafening roar, like thunder rolling through the ground. In Alaska's Tom Fjord in 2015, a landslide released so much material so quickly that it generated a tsunami over 600 feet high. These lightning-fast avalanches of Earth show that mountains are not as still as they seem. They can collapse in an instant, unleashing destructive power that rivals the fastest and most violent storms on the planet. A volcanic eruption once created an entirely new lake. Volcanoes do not only build mountains, they can also sculpt vast new lakes. When Mount Mazama erupted around 7,000 years ago in what is now Oregon, it expelled so much magma that the mountain collapsed inward, forming a massive crater. Over time, rain and snow filled the depression, creating Crater Lake, one of the deepest and most beautiful lakes in the world. Its waters are famously clear and blue, a tranquil reminder of violent origins. Similar events have happened elsewhere, as collapsed volcanic calderas become basins for water. These crater lakes are often ringed by steep cliffs, dramatic landscapes that show the outlines of their fiery birth. They remind us that destruction and creation are often inseparable. A single eruption can erase a mountain, yet in its absence, it may leave behind something breathtaking, a still, shimmering lake born from fire. Hurricanes can carry sharks inland. Storm surges and flooding from hurricanes have occasionally swept marine life far from the sea. In some extreme cases, eyewitnesses have reported sharks washed inland by surging waters, stranded in streets or fields once the flood receded. These events are rare but entirely possible, given the enormous volume of seawater pushed ashore during a major storm. Scientists studying storm surges note that fish, dolphins, and even small whales can be displaced when hurricanes reshape coastlines. For communities struck by these storms, the appearance of ocean predators in unexpected places adds a surreal twist to the devastation. It is a vivid reminder that hurricanes blur the boundaries between land and sea, carrying the ocean inland and leaving behind strange and sometimes dangerous surprises in their wake. A tsunami once circled the entire globe multiple times. When Krakatoa erupted in 1883, it generated tsunamis so powerful that they radiated outward across the oceans. Instruments at tide gauges recorded the waves circling the globe not once, but several times, detectable for days as they bounced back and forth around the planet. Though diminished in size, the waves carried the fingerprint of the eruption, a steady pulse that beat around the world's coastlines. This was one of the earliest events where scientists realized the global nature of tsunamis. A single eruption in one corner of the planet had left ripples that could be measured half a world away. Today, with sensitive instruments, we know that many tsunamis reverberate globally, echoing like bells long after the initial strike. They are planetary events, setting the oceans into oscillation until the energy finally dissipates. Earthquakes can make church bells ring miles away. During powerful earthquakes, the shaking can travel outward in seismic waves that ripple across entire regions. In rare cases, these waves are strong enough to set objects in motion far from the epicenter. Historical accounts describe church bells ringing on their own during earthquakes, even in towns miles from the shaking's source. One notable example occurred during the Great New Madrid earthquakes of the early 19th century in the central United States, when church bells in cities hundreds of miles away began tolling without human hands. The phenomenon happens because the vibrations resonate through the ground and into structures, transferring energy to hanging objects. Bells are especially sensitive, swinging just enough to strike their clappers. For those who lived through it, the sound of bells chiming during the chaos of an earthquake must have felt eerie, as though the earth itself were tolling its alarm in unison with human instruments. Some wildfires burn so hot, they create their own clouds. Most clouds form when water vapor condenses in the sky, but in the heart of an intense wildfire, a different kind of cloud can be born. These are pyrocumulonimbus clouds, vast, thunderous towers created when extreme heat drives smoke and hot air skyward. The rising column can climb tens of thousands of feet, cooling at the top until moisture condenses. The result is a cloud that looks like a thunderstorm, but is fueled by fire. Inside, lightning crackles, sometimes sparking new blazes miles away. These fireborne storms are so intense that satellites can see them from orbit, glowing plumes rising into the stratosphere. They are among the most dramatic examples of how wildfires reshape the atmosphere, turning fire into weather. Witnessing one is to see the line between earth and sky blur, as heat and smoke climb upward until they transform into a storm all their own. Avalanches can release more power than an exploding bomb. An avalanche may look like a simple rush of snow, but the energy locked inside its falling mass is staggering. As snow and ice cascade down a slope, their combined weight and acceleration release energy equal to small explosives, sometimes rivaling the force of man-made bombs. A large avalanche can unleash the energy of hundreds of tons of TNT in a matter of minutes. This power snaps trees like twigs, buries valleys, and scours mountain slopes bare. Survivors describe the experience as being caught inside a roaring freight train, the snow dense and suffocating, carrying unimaginable force. Scientists studying avalanches compare their destructive potential to artillery fire, with pressure waves strong enough to collapse structures even before the snow arrives. These massive torrents remind us that snow, which often falls so gently, can gather in layers that hold devastating strength, waiting only for the slightest trigger to thunder downhill. Hurricanes can grow stronger overnight by feeding on warm water. Hurricanes are powered by heat. As long as they remain over warm ocean waters, they draw energy from the endless reservoir beneath them. Sometimes this fueling process can cause sudden, unexpected surges in strength known as rapid intensification. A storm that seemed manageable in the evening can awaken the next morning as a monster, its winds doubled, its pressure plummeted. This phenomenon has been observed in several recent hurricanes, leaving communities scrambling with little time to prepare. The process occurs when ocean temperatures are especially high and upper-level winds are calm, allowing the storm's heat engine to run without interference. For scientists and forecasters, predicting these bursts is a constant challenge. For those who witness them, the transformation feels almost alive, as though the storm itself had taken a deep breath from the ocean and grown more powerful in the blink of an eye. The Dust Bowl was a disaster of wind, soil, and human choices. In the 1930s, the American Great Plains experienced one of the most devastating environmental disasters in history. Years of drought combined with decades of aggressive farming practices that had stripped the land of protective grasses. When winds swept across the plains, they lifted the exposed soil into enormous dust storms. These storms darkened skies for hours, burying towns and choking livestock. Families found their homes filled with dust despite closed windows and doors. Entire farms were abandoned, and many families migrated west in search of survival. The Dust Bowl was not caused by a single event, but by the combination of natural drought and human decisions. It is a reminder that disasters are not always sudden earthquakes or storms. Sometimes they unfold slowly, shaped by the way people live with the land. The legacy of the Dust Bowl still echoes in lessons about soil, water, and human responsibility. Some earthquakes last for only a few seconds, others for several minutes. Not all earthquakes feel the same. Some strike with a sharp jolt, rattling windows and toppling objects in only a few seconds before fading. Others rumble on for long, dreadful minutes, rolling through the ground in waves that seem endless. The difference lies in the length of the fault line that slips and the amount of energy released. Small quakes may release their energy quickly, while massive ones, such as the 9.5 magnitude Chilean quake of 1960, rupture faults stretching hundreds of miles, shaking for up to 10 minutes. For those experiencing it, time stretches unbearably. A few seconds can feel like forever, but minutes of shaking are unforgettable as buildings sway, ground cracks open, and the world refuses to steady. Earthquakes remind us that time is not only measured on clocks, sometimes it is felt in the unrelenting rhythm of a planet in motion. Tsunamis move faster than a race car even in deep water. When an earthquake or landslide displaces the seafloor, the resulting tsunami carries an immense amount of energy. In the open ocean, this energy spreads through the full depth of the water, propelling the wave forward at astonishing speeds. Some tsunamis travel at over 500 miles per hour, faster than most race cars. Out in deep water, the waves may be only a few feet high, almost invisible to passing ships. Yet their speed makes them relentless, racing across oceans to distant coasts. Hours later, that same energy rises into walls of water that crash ashore, devastating everything in their path. The deceptive calm of a tsunami at sea is part of its danger. By the time it is visible near land, its journey has already spanned hundreds or even thousands of miles. Faster than human escape, these waves embody the unstoppable momentum of Earth's shifting crust. The deadliest volcano in recorded history darkened the sky for years. In April of 1815, Mount Tambora in Indonesia erupted with a force unmatched in modern history. The explosion ejected so much ash and sulfur dioxide into the atmosphere that it blocked sunlight for years. The year following the eruption became known as the year without a summer. Temperatures plunged across Europe and North America. Harvests failed, and famine spread. In some regions, snow fell in midsummer, and skies glowed with eerie sunsets. The eruption itself killed tens of thousands nearby, but its long-term climatic effects caused suffering for millions around the world. This single event showed how interconnected Earth's systems are. A volcanic mountain on one island altered the skies of the entire planet. Today, geologists study Tambora not only as history's deadliest eruption, but also as a warning of how even one explosion can tip the balance of life, far from its fiery source. Some tornadoes spin backwards compared to the usual direction. Most tornadoes in the Northern Hemisphere spin counterclockwise, shaped by the rotation of the Earth and prevailing wind patterns. But in rare cases, tornadoes form that rotate the opposite way, clockwise. These anticyclonic tornadoes are unusual, often appearing on the edges of storm systems or within complex weather patterns. Though generally less powerful than their counterclockwise cousins, they can still cause immense destruction. Meteorologists study them to understand the delicate balance of air currents that allows such reversed spirals to form. To witnesses on the ground, a backward spinning tornado looks no different, yet it reveals the strange flexibility of atmospheric physics. The sky does not always obey its own rules. Sometimes storms twist against the expected flow, creating whirlwinds that seem to defy the natural order. These rare tornadoes remind us that even within patterns we think we understand, the atmosphere keeps its own surprises. Earthquakes can break open new canyons in an instant. We usually imagine canyons as features carved slowly over millennia by rivers and erosion. But earthquakes can create dramatic new chasms in mere moments. During major quakes, the ground can split apart, leaving jagged fissures that stretch for miles. In the 1976 Tangshan earthquake in China, cracks opened wide enough to swallow cars. In New Zealand's 2010 quake, farmers awoke to find deep rifts cutting across their land, as though the earth itself had been sliced. These sudden ruptures may later erode into larger valleys, becoming permanent features of the landscape. For those who see them, the sight is unforgettable. Solid ground torn apart in minutes, exposing layers of rock usually hidden far below. Earthquakes remind us that while time often sculpts landscapes slowly, it can also act with shocking speed, reshaping the land in the span of a single, terrifying heartbeat. A volcano in Iceland once shut down air travel across Europe. In 2010, the eruption of Eyjafjallajökull in Iceland hurled massive plumes of volcanic ash high into the atmosphere. Winds carried the ash across northern Europe, where it posed a severe hazard to aircraft. Volcanic ash is composed of sharp, glassy particles that can melt inside jet engines, coating them in glass and causing catastrophic failures. As a result, aviation authorities grounded flights across Europe for nearly a week. Millions of passengers were stranded, and international commerce slowed to a crawl. It was one of the largest air travel disruptions in modern history, all caused by a relatively modest eruption from a single volcano. The event highlighted how interconnected our world is, and how something as natural as ash drifting through the sky can silence one of humanity's most advanced technologies. In the contest between Earth and machines, Earth still holds the upper hand. Some lightning strikes travel upward into space, while most lightning bolts dart downward from clouds toward the ground. Some do the opposite. Known as sprites and jets, these rare forms of lightning shoot upward into the upper atmosphere, and in some cases extend toward the edge of space. Sprites appear as vast, red, branching tendrils above thunderstorms, sometimes stretching for tens of miles. Blue jets, meanwhile, spear upward like glowing lances. These phenomena were first captured on camera only in recent decades, as they are fleeting and difficult to see from the ground. Astronauts aboard the International Space Station have observed them from above, glowing against the blackness of space. These upward strikes remind us that lightning is not just a ground-to-cloud event. It is part of a larger electrical ballet between Earth and sky, reaching higher than we once thought possible, connecting storms to the very edge of space. Landslides can generate waves taller than skyscrapers. When an enormous mass of rock and earth collapses into water, the displacement can create waves of staggering height. In 1958, a landslide in Alaska's Lituya Bay triggered a wave that reached over 1,700 feet, taller than most skyscrapers. Trees were stripped from mountainsides hundreds of feet above sea level, and the landscape was permanently altered. Scientists call these events mega-tsunamis, distinct from traditional tsunamis caused by earthquakes. The sheer volume of falling material pushes water upward in a violent surge, creating waves that dwarf anything seen in open ocean storms. Thankfully, such events are rare, confined to narrow bays and fjords where steep cliffs loom above the water. But they are a reminder of how gravity alone, pulling down the mountain slope, can unleash forces greater than most storms. A collapsing hillside can transform in seconds into the tallest waves on Earth. Earthquakes can be so strong they make the Earth ring like a bell. When a massive earthquake strikes, its energy does not stay local. Seismic waves ripple through the entire planet, reverberating from core to crust. Sensitive instruments have recorded Earth ringing for days afterward, as if the whole planet were a struck bell slowly quieting. The 1964 Alaska quake and the 2004 Indian Ocean quake both sent low-frequency vibrations pulsing around the globe. These vibrations are too slow for humans to feel, but seismographs capture them as ghostly oscillations that circle Earth again and again. Scientists study these planetary vibrations to learn about the structure of Earth's interior, using disasters as accidental experiments. Though terrifying in their impact on human life, these quakes reveal the planet as a resonant body, humming with deep tones. In the aftermath of destruction, Earth itself becomes an instrument, singing its hidden song across the vastness of its own sphere. Some hurricanes have eyes so clear you can see stars through them. At the heart of the hurricane lies the eye, a calm region where winds die down and skies often open. Pilots who fly into storms describe the experience as surreal. After battling through walls of fierce winds and rain, they suddenly emerge into stillness. Sometimes, the eye is so clear that the blue sky and even stars at night are visible, framed by towering walls of cloud on every side. From the ground, people caught in the eye may believe the storm has ended, only to face the fury of the eye wall minutes later when winds return from the opposite direction. These clear eyes are rare and fleeting, yet they reveal the strange order within chaos. A hurricane, for all its violence, organizes itself around a silent, tranquil core, a reminder that even in the wildest storms, nature keeps a hidden balance. Tsunamis can be triggered by meteor strikes. Though most tsunamis are caused by earthquakes or landslides, scientists know that a large meteor plunging into the ocean could unleash waves of unimaginable scale. When an asteroid strikes, it displaces massive amounts of water almost instantly, sending tsunamis racing outward in all directions. Geological evidence suggests that when the asteroid that ended the age of the dinosaurs struck 66 million years ago, it generated waves hundreds of feet high, reshaping coastlines across the world. Modern computer models show that even smaller strikes could devastate ocean basins, sending destructive waves across thousands of miles. While rare, these events remind us that Earth is not only shaped by forces within, but also by objects arriving from space. The ocean, vast and deep, can become a transmitter of cosmic impacts, turning a single falling rock into a planetary disaster. Tornadoes can make grass lie flat in perfect circles. After a tornado passes, the marks it leaves on the landscape are often strange and beautiful, as well as destructive. One eerie signature is the way grass is sometimes pressed flat in precise, circular patterns. These swirls form when the tornado's winds spiral downward, pressing vegetation into the ground as though a giant invisible hand had smoothed it. Farmers have reported entire fields patterned with concentric rings after storms, resembling crop circles created by nature herself. Scientists study these imprints to understand the structure of tornado winds near the ground, where the storm interacts with the surface. To walk through such a field after a storm is unsettling, the silence of flattened grass whispering of the chaos that spun above it. These circular scars are delicate signatures of one of nature's most violent phenomena, patterns of order drawn out of disorder. Earthquakes can cause rivers to vanish into the ground. In some regions, earthquakes have the uncanny ability to make rivers disappear. When the ground shifts, it can open new cracks or block old channels, diverting water underground. Historical records from China and South America describe rivers suddenly drying up after quakes, their waters swallowed by new fissures in the earth. In some cases, entire streams are redirected, creating new courses that reshape landscapes permanently. For communities relying on those rivers, the disappearance can be catastrophic, cutting off vital sources of water in an instant. Scientists studying such events note that groundwater systems are highly sensitive to seismic shifts. What seems like solid riverbeds may in fact be thin skins over porous stone, vulnerable to collapse. These vanishing rivers are haunting reminders that water, like the land itself, follows the path Earth demands, disappearing when the ground decides to open and swallow it whole. Volcanic ash can travel around the world in days. When a volcano erupts explosively, it throws ash and fine particles high into the atmosphere. At these altitudes, winds can carry the ash across entire continents in just days. After the eruption of Mount Pinatubo in 1991, ash circled the globe, dimming sunlight and creating brilliant sunsets thousands of miles away. Pilots flying in distant regions reported hazy skies, unaware that the particles they saw had come from halfway around the world. Ash clouds this widespread can disrupt global weather, cool temperatures, and affect aviation far beyond the eruption site. The journey of volcanic ash shows how interconnected Earth's atmosphere truly is. What begins in one corner of the world may touch skies everywhere. A single mountain's outburst can leave its fingerprint across the globe, written in veiled sunsets and faint layers of dust drifting high above. Some ice storms cover trees in crystal coats inches thick. Ice storms are among the most visually enchanting natural disasters. As freezing rain falls, it coats every surface it touches, layering branches, wires, and rooftops in gleaming glass. In severe storms, these coatings can grow several inches thick, turning entire forests into crystalline sculptures. The weight, however, is devastating. Branches snap, trees topple, and power lines sag under hundreds of pounds of added ice. From a distance, the aftermath may look like a sparkling wonderland, but the destruction is immense. Roads become impassable sheets, and neighborhoods are plunged into cold darkness as power grids collapse. For those who live through them, ice storms bring both awe and hardship. They reveal the dual nature of nature's artistry, breathtaking beauty carved in frozen light, balanced against the crushing power of ice to break what stands beneath its glittering weight. Hurricanes can grow large enough to cover entire countries. From orbit, hurricanes resemble great spirals painted across the ocean, but their true scale is even more astonishing. Some storms grow so vast that they span entire countries, covering hundreds of miles from edge to edge. In 2005, Hurricane Katrina stretched across much of the Gulf of Mexico, its cloud shield engulfing several states at once. In 2017, Hurricane Irma's reach was so wide that it covered nearly all of Florida simultaneously. Within these immense systems, the eye may appear small, a tranquil circle surrounded by towering walls of cloud, yet the storm's arms stretch outward for hundreds of miles, pulling in moisture and unleashing rain bands far. From the center, standing beneath one of these sprawling storms, is to realize how tiny human structures are compared to the scale of Earth's atmosphere. Entire countries disappear beneath the swirl, hidden under a living, breathing machine of air and water. Earthquakes can create natural dams. When mountainsides collapse during powerful earthquakes, the debris often blocks rivers, forming natural dams in an instant. These sudden barriers can hold back enormous lakes, sometimes stretching for miles. One dramatic example occurred after the 2008 Sichuan earthquake in China, where dozens of such quake lakes appeared, many threatening to burst and flood downstream villages. While some of these natural dams last for centuries, others are unstable, collapsing with catastrophic results. The process is both destructive and creative. A valley is buried, yet a lake is born. Over time, these new lakes may become havens for wildlife, feeding birds, fish, and forests along their shores. But in the days after the quake, they stand as precarious reminders of the Earth's shifting balance, holding back waters that might one day surge free again. A single tremor can turn a flowing river into a still, reflective mirror of stone and water. Volcanic eruptions have changed the color of sunsets worldwide. After massive eruptions, the sky becomes a canvas for strange, fiery colors. Volcanic ash and sulfur particles scatter sunlight in unusual ways, creating sunsets and sunrises that glow with intense reds, purples, and oranges. In the 19th century, the eruption of Krakatoa filled skies across the globe with vivid displays that inspired painters and poets. Some believe that Edvard Munch's famous painting The Scream captures the blood-red skies left by volcanic haze. In the 1990s, Mount Pinatubo's eruption dimmed sunlight worldwide and set the stage for unusually brilliant sunsets for years. These spectacles remind us that volcanoes are not only destructive forces, but also artists in the sky, altering the light that bathes the Earth. While their ash can cool climates and devastate agriculture, it also leaves behind fleeting moments of beauty, when the entire planet shares in a fiery twilight painted by a mountain's eruption. Fire whirls can leap across roads and rivers. In the chaos of a wildfire, walls of flame sometimes give rise to spinning vortices of fire whirls. These twisters of flame form when heat and wind combine to spin columns of air, drawing burning debris upward. Unlike ordinary tornadoes, they feed on fire, carrying embers and sparks high into the sky. Eyewitnesses have reported fire whirls leaping across roads, highways, and even rivers, igniting new blazes far beyond the original fire line. In some cases, they can rise hundreds of feet and behave like fiery bridges, connecting one burning region to another. Their unpredictable movements make them especially dangerous, as they spread fire with explosive speed. To stand before one is to witness the terrifying marriage of wind and flame, a reminder that in nature, fire is not bound by barriers we consider protective. Even rivers cannot stop a fire when it begins to spin. Tsunamis can carry ships deep inland. The power of a tsunami is perhaps best illustrated by the images it leaves behind. Massive ships resting in streets, fields, or atop buildings far from the shore. During the 2011 Tohoku tsunami in Japan, fishing boats, freighters, and even large vessels were lifted from harbors and carried miles inland, deposited on rooftops or wedged among houses. The sheer mass of these ships, some weighing thousands of tons, matters little to the momentum of a tsunami. The waves act not like ordinary water, but as moving walls of ocean, lifting whatever they encounter and sweeping it along. For survivors, a sight of ships stranded in neighborhoods was surreal, evidence of the ocean's strength to rearrange the familiar world. These displaced giants are haunting reminders that when the sea decides to move, it can carry even the heaviest creations of humankind wherever it wishes. Tornadoes can lift cows and drop them miles away. Tornadoes are infamous for their ability to fling debris, but historical accounts and eyewitness reports tell of something even stranger: livestock lifted and carried away. Farmers have watched in shock as tornado funnels plucked cows, horses, or sheep from pastures, spinning them upward like weightless objects. In some cases, the animals have been found miles away, alive but shaken. More often, they are lost amid the debris, reminders of the funnel's merciless power. The mechanics are simple but devastating. Tornado winds, often exceeding 200 miles per hour, create pressure drops that lift and hurl anything in their path, regardless of size. While stories of airborne cows are sometimes exaggerated, enough reliable reports exist to confirm their possibility. These bizarre events highlight the surreal nature of tornadoes, where the ordinary order of life is overturned, and even creatures weighing hundreds of pounds can be whisked into the sky. Avalanches can snap trees like toothpicks. When an avalanche races down a mountain, it is not only snow that moves. Entire forests can be consumed by the roaring flow. Trees, centuries old, are snapped and uprooted as though they were fragile twigs. Survivors describe slopes after avalanches as wastelands, bare scars of rock where forests once stood. The combined mass of snow, ice, and debris exerts pressure impossible for even the strongest trees to withstand. Avalanches can flatten acres of forest in minutes, leaving behind tangled piles of trunks and branches. The destruction is so complete that new growth may take decades or even centuries to return. To witness the aftermath is to see the sheer dominance of gravity, reminding us that mountains are not fixed but constantly reshaped. In an instant, a wooded slope can be transformed into a barren scar, written by the unstoppable momentum of falling snow. Some earthquakes make the ground open and swallow buildings. When the earth shifts violently, it sometimes tears open fissures wide enough to engulf entire structures. In parts of Mexico, Turkey, and China, historical quakes have opened rifts in the ground that consumed houses, barns, and even sections of roads. These chasms are created when the crust pulls apart under sudden stress, leaving gaps that collapse inward. For survivors, the sight is terrifying. The illusion of solid ground vanishes as the earth itself splits open. Though not as common as shaking and collapse, these fissures highlight the unpredictability of seismic events. They can appear suddenly, stretching for miles and reshaping the land in moments. Buildings that once seemed immovable vanish into the earth, swallowed by the planet's shifting plates. Such sights leave lasting scars, not only on landscapes, but also on the memory of those who witnessed the earth literally opening beneath their feet. Hurricanes can toss cars through the air. In the most violent hurricanes, winds reach speeds strong enough to lift vehicles from the ground and hurl them like toys. Videos from storms in the Gulf Coast and the Caribbean show cars tumbling end over end, carried by gusts exceeding 150 miles per hour. These winds generate pressure differences that reduce the grip of tires on pavement, making even heavy vehicles vulnerable. Once airborne, cars become dangerous projectiles, colliding with buildings and infrastructure. Emergency responders warn residents never to rely on vehicles for protection in hurricanes, as they can be swept away in both wind and floodwaters. To see a car tossed into the air by wind alone is a surreal reminder of scale. Machines built from steel, designed for speed and power, are rendered helpless against the atmosphere's furious strength. The storm decides what stays rooted and what takes flight. The largest landslide ever recorded moved more earth than a mountain. In May of 1970, the flank of Mount Huascaran in Peru collapsed after a massive earthquake. In seconds, a staggering mass of rock, ice, and debris thundered down the mountain, burying entire towns. The landslide traveled at terrifying speeds, carrying more earth than many mountains contain. Entire villages were erased, and tens of thousands of lives were lost. Scientists studying the event estimate that the volume of material moved was so immense it could have filled vast valleys. Unlike slow erosion that carves mountains over millennia, this landslide reshaped the landscape in an instant. Today, satellite images reveal the scar left behind, a permanent reminder of the moment when a mountain fell. It remains one of the largest landslides in recorded history, an example of how even the seemingly immovable peaks of Earth can crumble and flow like water under the right conditions. Earthquakes can be triggered by the melting of glaciers. The weight of glaciers presses down on the crust, holding faults beneath them in place. When glaciers melt, whether from natural cycles or modern climate change, that immense weight is lifted. The crust, freed from its icy burden, begins to rebound, and sometimes that rebound triggers earthquakes. In regions like Greenland and Alaska, scientists have recorded quakes linked to the retreat of glaciers. This process, called isostatic rebound, shows how intimately connected Earth's systems are: ice, climate, and tectonics woven into a single web. While these glacially triggered quakes are often smaller than major tectonic events, they can still shake landscapes already vulnerable to change. It is a reminder that even slow, steady melting can awaken sudden violence beneath the Earth, as the ground itself adjusts to the shifting balance of weight above it. A volcano in the Pacific once created an island that vanished again. In 2015, an undersea eruption in the Pacific Ocean gave rise to a new island near Tonga. For months, curious observers watched as steam, ash, and lava piled up until land emerged from the sea. The island was home to seabirds and even colonized by plants blown in on the wind. But only a few years later, waves and erosion reclaimed it, washing the volcanic creation back beneath the waves. This story is not unique. Many volcanic islands are temporary, appearing after eruptions only to vanish again within decades or centuries. The Pacific is dotted with such ephemeral lands, proof that the boundary between sea and land is not fixed. For a brief moment, a new island may stand tall, but the ocean always decides whether it will endure or disappear back into the deep. Some tsunamis are invisible until they reach shore. In the open ocean, a tsunami may be nearly impossible to notice. Unlike storm waves, which have short crests and are easily visible, tsunami waves have enormous wavelengths, sometimes stretching hundreds of miles. At sea, the wave may only be a few feet high, passing unnoticed beneath ships. But when that same wave reaches shallow water near shore, its energy is forced upward, transforming into a towering wall. This deceptive nature makes tsunamis particularly dangerous. Hours may pass between the triggering earthquake and the arrival of the wave, yet those at sea might never know one is racing beneath them. Only as the ocean pulls back, exposing the seafloor in eerie silence, do coastal communities realize what is coming. By then, the immense wave is seconds away. Tsunamis teach us that danger is not always visible. Sometimes it hides in plain sight, waiting to rise. Tornadoes can be nearly invisible until they pick up dust or debris. When most people picture tornadoes, they imagine dark funnels twisting across the sky. But some tornadoes are nearly invisible. Made only of swirling air, they cannot be seen until they gather dust, dirt, or moisture. These clear tornadoes are especially dangerous, as their destructive winds may be present without warning signs. Pilots have reported airborne funnels that are detectable only by the violent turbulence they create, and farmers have seen tornadoes crossing fields unseen until they strike a barn or scatter debris. In dry regions, invisible tornadoes can pass silently, revealed only by sudden destruction in their wake. These ghostly whirlwinds remind us that tornadoes are not defined by appearance, but by motion. Whether wrapped in dust or hidden in clear skies, they are the atmosphere unleashed in a spiral of destruction, sometimes seen only in the damage they leave behind. Hurricanes can reshape entire coastlines in a single storm. The combined force of hurricane winds, waves, and storm surge can permanently alter coastlines. Barrier islands are cut in half, beaches vanish, and new inlets appear where none existed before. In 2005, Hurricane Katrina carved new channels through Louisiana's wetlands, erasing stretches of land overnight. In 2012, Hurricane Sandy pushed water deep into New Jersey and New York, altering shorelines for years to come. These changes happen because hurricanes concentrate enormous energy into a brief span, battering landforms that normally shift over centuries. Entire maps can become outdated after a single storm. What was once a familiar stretch of beach may be gone forever, replaced by marshes, channels, or open sea. Hurricanes are not just weather events, they are geological forces, rewriting coastlines in ways that shape communities, ecosystems, and human memory. Earthquakes can reverse the flow of underground springs. Beneath the surface, water flows through networks of channels and porous rock, forming springs that bubble up into rivers and streams. Earthquakes can disturb these delicate pathways, compressing some regions and expanding others. In rare cases, this has caused underground springs to reverse their flow, sending water back into the earth instead of out. After major quakes in Japan and New Zealand, residents reported springs that had flowed for centuries suddenly drying up, while others surged stronger than ever. For communities relying on these natural water sources, the changes were profound. These reversals remind us that groundwater systems are living networks, constantly shaped by the shifting crust. An earthquake is not just felt on the surface, it echoes into hidden aquifers, rewriting the unseen plumbing of the earth in ways that can last for generations. Volcanic ash clouds can block out the sun for months. When a volcano erupts with exceptional force, the ash cloud can rise high into the stratosphere, beyond the reach of rain that might otherwise wash it away. Once there, fine ash and sulfur dioxide can linger for months, dimming sunlight across continents. The eruption of Mount Pinatubo in 1991 reduced global temperatures by nearly a degree for several years, thanks to the persistent veil of particles. In earlier centuries, eruptions like Tambora's darkened skies worldwide, with sunsets glowing red for months. These long-lasting clouds are both beautiful and dangerous. They cool the climate, disrupt agriculture, and alter weather patterns. Yet they also create otherworldly skies that remind us of Earth's fragility. The sight of dimmed sunlight filtering through volcanic haze is a haunting reminder that even the brightest star in our sky can be muted when Earth decides to release its ash. Firestorms can create winds stronger than hurricanes. When entire cities or forests burn intensely enough, the rising heat can generate its own wind system. These are firestorms, blazes so vast and hot that they pull in air from all directions, creating gale-force winds to feed themselves. In Dresden, during World War II, firestorms created winds over 100 miles per hour, sucking people and debris into the flames. In wildlands, similar events have been recorded, with forests consumed by blazes that roar like hurricanes. The physics is simple, yet terrifying. Heat rises, pressure drops, and surrounding air rushes inward to fill the void. The result is a storm made of fire, winds, and flames working in unison. Unlike hurricanes, which eventually dissipate over land, firestorms end only when fuel is gone. They show us how fire, once large enough, ceases to be an event and becomes its own atmospheric system of destruction. Tsunamis can be triggered by submarine landslides. Not all tsunamis are caused by earthquakes. Sometimes massive landslides occur beneath the sea, displacing vast volumes of water and setting off waves that rival those from tectonic shifts. These submarine landslides may happen when sediments piled along continental shelves suddenly collapse. Scientists studying ancient deposits have found evidence of landslide-triggered tsunamis that were hundreds of feet tall. reaching distant coastlines with devastating force. Unlike earthquake tsunamis, which may give some warning, these can strike with almost no notice, as the collapse itself is the trigger. Modern monitoring systems are beginning to detect such events, but they remain among the least predictable of ocean disasters. They remind us that the seafloor is not stable ground, but a shifting landscape, where hidden avalanches can move millions of tons of material and set the ocean itself into violent motion. Tornadoes can lift asphalt right off roads. The strongest tornadoes leave behind scars that defy belief. In some cases, winds have been so intense that they peeled asphalt from highways, leaving bare dirt where paved roads once ran. This happens because tornado winds create extreme pressure differences, combined with the force of debris battering the surface. Asphalt, which seems immovable under ordinary circumstances, can be ripped apart and carried away. After the tri-state tornado of 1925, and more recently in Oklahoma storms, investigators documented roads stripped bare, as if giant claws had raked across them. Such evidence demonstrates just how violent these funnels can be, not only lifting houses and cars, but also tearing into the very ground we build upon. A road designed to endure decades of traffic stands no chance against the atmospheric violence of a tornado at its peak. Earthquakes can be felt on the other side of the planet. When a massive earthquake shakes one part of the Earth, the energy does not stop at the epicenter. Instead, seismic waves radiate outward, traveling through the crust, mantle, and even the core. Sensitive instruments called seismographs pick up these vibrations on the far side of the world, thousands of miles away. After the 9.1 magnitude quake off Sumatra in 2004, seismographs from California to Africa recorded the planet trembling. To people, these faraway ripples are often too faint to notice. But occasionally, if the quake is enormous, subtle motions may be felt half a world away. It's as though the Earth itself is a bell, and the quake is the hammer strike, sending deep tones that resonate around the globe. These quakes remind us that the world beneath our feet is interconnected. One violent slip along a fault can send shudders through the entire sphere we call home. Hurricanes can carry salt spray miles inland. The force of hurricane winds doesn't only move rain and debris, it also lifts seawater into the air, creating salty spray that can travel far inland. When hurricanes make landfall, this invisible mist can be carried for dozens of miles, coating trees, crops, and buildings in layers of salt. Farmers have returned after storms to find fields burned brown, not by fire, but by salt crystals clinging to leaves. In some cases, freshwater lakes and rivers have been contaminated with seawater, altering ecosystems for months or even years. The salty air also corrodes metal, rusting cars, bridges, and machinery long after the winds have died. For coastal communities, the hurricane surge is not the only ocean that invades the land. Even in areas untouched by flooding, the sea arrives through the air itself, carried on storm winds until salt falls like a ghostly shadow across the countryside. Some volcanoes erupt with glowing rivers of ice and fire. In rare places where glaciers crown volcanic peaks, eruptions create surreal spectacles, glowing rivers of lava flowing beneath or through ice. When fire meets ice, explosive interactions occur. The lava melts vast amounts of glacial ice in moments, sending floods of scalding water surging down valleys. In Iceland, eruptions beneath glaciers have produced massive glacial outburst floods, known locally as Jökullaups, capable of sweeping away bridges and reshaping landscapes overnight. At the same time, molten rock continues to glow red-hot, carving tunnels beneath sheets of white ice. Steam rises in immense columns as two of nature's fiercest opposites collide. To stand near such an eruption is to see contradictions made real. rivers that glow with fire yet flow beneath frozen armor, landscapes that tremble with both flame and frost. These rare eruptions are proof that Earth's extremes do not cancel each other, but merge to create wonders unlike anything else. Earthquakes can shatter glass windows hundreds of miles away. Even far from the epicenter, an earthquake's waves can travel through the ground with enough energy to rattle and even shatter windows. During the Great Alaska Quake of 1964, glass panes cracked and fell out in Seattle, more than 1,000 miles away. Vibrations from large quakes arrive in pulses, some fast and sharp, others long and rolling. These waves can cause tall buildings and windows to sway in resonance, amplifying their motion until glass snaps. For residents far from the quake's source, the shock can be unnerving. To feel only a mild shake, yet see windows burst or hear glass shatter suddenly. These distant effects illustrate how powerful seismic waves truly are, crossing continents and oceans with little loss of strength. Earthquakes remind us that the Earth is not solid and still, but flexible, echoing vibrations outward like ripples through a cosmic drum. The strongest tornadoes can level entire towns. While smaller tornadoes may damage roofs or scatter debris, the strongest, classified as EF5 on the enhanced Fujita scale, have the power to obliterate entire communities. In these rare but catastrophic storms, winds exceeding 200 miles per hour can strip houses down to their foundations, topple schools, and scatter neighborhoods into fields of rubble. The Joplin tornado of 2011 and the Tri-State tornado of 1925 left towns unrecognizable, reducing one's busy streets to bare earth. Cars were flung like toys, steel beams twisted, and trees stripped of bark. Survivors described silence after the funnel passed, as though the town had been erased in moments. Such tornadoes are mercifully rare, but when they do strike, they demonstrate atmospheric violence at its absolute peak. A place that once held lives, memories, and homes can be transformed into emptiness in minutes. Tsunamis can travel at the speed of a passenger jet. In the deep ocean, tsunamis race forward with astonishing speed, up to 500 or even 600 miles per hour, as fast as a commercial airliner. Out at sea, their waves are barely noticeable, sometimes only a few feet high. Ships may sail directly over them without realizing what has passed beneath. Yet the energy inside these waves is immense, spread throughout the full depth of the ocean. When the tsunami reaches shallow water, all of that energy is forced upward, transforming the Ennis-invisible swell into a towering wall of destruction. What began as a near-silent ripple in the middle of the sea becomes a catastrophe at shorelines hundreds or thousands of miles away. The sheer speed of tsunamis makes them nearly impossible to outrun, even for aircraft. They are oceanic shockwaves, reminders that water in motion can rival the pace of machines built for the skies. Volcanic eruptions have created entire mountain ranges. Mountains are usually thought of as ancient and immovable, but many of the world's most dramatic ranges were born from volcanic fire. The Andes, stretching down South America, were built in large part by countless eruptions over millions of years. Each eruption piled new layers of lava and ash atop the last, building peaks that now soar thousands of feet into the sky. In the Pacific, chains of islands like Hawaii are simply mountain ranges that rise from the sea floor, their tips visible above the waves, created one eruption at a time. Even now, volcanoes continue to add new height and breadth to ranges worldwide. What appears as timeless stone is, in truth, frozen fire. Mountains sculpted from molten rock, hardened into enduring monuments. To stand among them is to stand in the shadow of Earth's fiery past, a past that continues to rise toward the sky, Hurricanes can be visible from space as swirling giants. When astronauts look down from orbit, hurricanes are among the most breathtaking and intimidating sights. From space, they appear as massive white spirals, stretching hundreds of miles across, slowly turning over the ocean. At the center lies the eye, a dark circle of eerie calm, surrounded by towering walls of cloud that rise like cliffs. The view is both beautiful and humbling, a storm so vast it covers entire regions, yet delicate enough to reveal intricate spirals and bands of rain. Satellite images capture these giants with astonishing detail, showing storms that look almost alive, their arms reaching outward like cosmic pinwheels. From above, the destructive fury felt on the ground is transformed into a silent, mesmerizing dance of clouds. Hurricanes remind us that even the most violent disasters are also works of atmospheric art, patterns of order and chaos visible from the edge of space itself. Earthquakes can turn forests into swamps. In some regions, powerful earthquakes liquefy the ground, mixing soil and water until the land behaves like quicksand. Entire forests rooted in solid earth can suddenly sink, trees half submerged as the ground beneath them turns liquid. After the 2010 earthquake in Chile, large tracts of forested land became marshes overnight, with tree trunks jutting out from shallow lakes. This happens because seismic shaking forces groundwater upward, loosening soil until it loses its strength. For ecosystems, the change can be profound. Dry woodland becomes wetland, with new species moving in even as the old perish. To walk through such a place is unsettling, the ground soft and unstable, the air damp where it once was dry. Earthquakes remind us that landscapes are not fixed. In moments they can transform, trading forest for swamp, dry land for water, stability for fluidity. The biggest wildfires can create smoke plumes that reach the stratosphere. Most smoke rises only into the lower atmosphere, but the largest wildfires, burning with extreme intensity, can loft their plumes into the stratosphere, higher than where commercial jets fly. These colossal columns, sometimes called pyrocumulus towers, can stretch miles into the sky, visible from hundreds of miles away. In recent years, megafires in Australia and North America have injected smoke so high that it circled the globe, dimming sunlight on distant continents. Unlike ordinary smoke, which dissipates quickly, stratospheric plumes can linger for months, affecting weather and cooling the climate slightly. Satellites capture them as hazy streaks across the planet, fingerprints of fire visible from orbit. For those on the ground, the sight is apocalyptic, the sky turning orange or black, daylight fading beneath a smoke-filled sun. Wildfires are not only local disasters, at their largest, they are planetary events, reshaping skies for the entire world. Some tornadoes have multiple whirling funnels. Most tornadoes consist of a single funnel, but sometimes the storm splits into several whirling vortices rotating around the same center. These multivortex tornadoes are among the most destructive, as each smaller funnel carves its own path of chaos, converging and diverging unpredictably. Witnesses describe seeing 3, 4, or even more slender funnels dancing around a central column, each powerful enough to level buildings. From the air, the effect resembles a writhing cluster of snakes, spiraling downward from the clouds. The damage patterns left on the ground are equally strange, multiple parallel paths of destruction, crossing and overlapping in ways that puzzle investigators. These multi-funnel storms demonstrate the complexity of tornado dynamics, where the atmosphere splits its fury into multiple spirals at once. For those caught beneath them, the sight is unforgettable. Not one tornado, but many, circling in a deadly dance. Tsunamis can carry boulders the size of houses. The power of a tsunami is revealed not only in the water it moves, but in the objects it drags along. In coastal regions struck by massive waves, geologists have found boulders weighing hundreds of tons, lifted from the seafloor and deposited far inland. Some of these stones are as large as houses, impossibly heavy to be moved by any human effort, yet casually carried by the force of water. After tsunamis in Japan, the Mediterranean and the Pacific Islands, such boulders have been left stranded on hillsides or fields, silent monuments to the waves that lifted them. These giant stones serve as geological records, evidence of ancient tsunamis far larger than any in modern memory. To see a house-sized rock resting in a meadow is to glimpse the ocean's raw power, a reminder that water in motion can move mountains, if only for a moment. Earthquakes can cause landslides under the sea. Not all landslides happen on mountainsides. Beneath the waves, the sea floor is steep and unstable in many places. When earthquakes strike, they can trigger underwater avalanches of mud, sand, and rock. These submarine landslides displace enormous volumes of water, sometimes setting off tsunamis as devastating as those caused by tectonic shifts. Evidence of such slides can be found in deep-sea canyons, where sediments have collapsed and flowed for miles. The largest underwater landslides dwarf anything seen on land, moving hundreds of cubic miles of material. For scientists, these hidden events are difficult to study, but their traces in the geological record reveal their immense power. They remind us that the ocean floor is not still but alive with shifting forces. Beneath the calm surface of the sea, entire landscapes can collapse in an instant, sending ripples that rise to the surface as towering waves. Volcanic eruptions can release lightning that flashes hundreds of times per minute. When volcanoes erupt explosively, towering ash plumes rise into the sky, filled with jagged particles rubbing violently against one another. This friction generates static electricity, unleashing bolts of volcanic lightning that streak through the clouds. During major eruptions, scientists have recorded hundreds of flashes per minute, turning the sky into a strobe of fire and electricity. The sight is otherworldly, a storm born of both earth and sky, where fire calls down lightning again and again. Some eruptions, like those of Mount Sakurajima in Japan, are famous for their lightning displays, attracting photographers who capture the eerie beauty. For those nearby, however, the experience is terrifying, as deafening thunder mingles with the roar of the eruption. Volcanic lightning shows us that disasters do not exist in isolation. Fire can summon storms, ash can create thunder, and Earth itself can call the sky to rage. Hurricanes can grow stronger just before making landfall. As hurricanes move across warm coastal waters, they sometimes surge in strength at the very last moment, just before reaching shore. This process, known as rapid intensification, transforms what seemed like a manageable storm into a deadly catastrophe. In 2021, Hurricane Ida strengthened dramatically just hours before striking Louisiana, catching many by surprise. Scientists believe shallow coastal waters warmed by summer sun provide the final fuel, and calm upper winds allow the storm's core to tighten. The communities waiting inland, this sudden escalation is terrifying, as forecasts change at the last minute from warnings to emergencies. The phenomenon illustrates the difficulty of predicting nature's extremes. Hurricanes are living systems, responding to heat and wind minute by minute. Just when people hope they are weakening, the storms may take one last breath of ocean warmth and roar ashore at their most powerful. Some avalanches release so much snow they bury valleys for months. The largest avalanches do more than rush down slopes. They can bury entire valleys under layers of snow so deep that it takes months for it all to melt. In the high Himalayas, Avalanches have filled valleys with debris and snow dozens of feet thick, creating natural barriers that linger long into summer. These frozen floods block rivers, form temporary lakes, and cut off communities until the thaw finally comes. For those trapped, the world outside becomes unreachable, buried under a white desert that swallows forests and homes alike. Scientists studying avalanche debris find massive blocks of ice compressed into strange formations, as though the mountain itself had collapsed in slow motion. These avalanches remind us that snow is not always fleeting. Sometimes it falls with such force and in such quantity that it reshapes landscapes for seasons, leaving whole valleys trapped beneath winter's grip. Earthquakes can shift the course of rivers forever. When the ground moves during earthquakes, it sometimes tilts entire landscapes, diverting rivers into new channels. After the New Madrid earthquakes in the early 1800s, parts of the Mississippi River briefly flowed backward before carving a slightly new path. In China and Alaska, quakes have redirected streams permanently, sending water into valleys that had been dry for centuries. These changes are not temporary. Once a river finds a lower path, it often keeps it, rewriting maps in the process. For communities along the banks, the consequences can be dramatic. Farmland cut off, towns left dry, or new floods threatening places once safe. Earthquakes demonstrate that rivers are not permanent fixtures. They are travelers across the land, and when the earth shakes, they may choose entirely new directions, flowing differently for centuries or even millennia to come. Tsunamis can travel thousands of miles to strike unexpected shores. Unlike ordinary waves, tsunamis retain their energy across entire oceans. A wave triggered in one hemisphere may still cause devastation on the far side of the world. After the Chilean earthquake of 1960, tsunamis raced across the Pacific, striking Japan and the Philippines more than 20 hours later. The Indian Ocean tsunami of 2004 was recorded as far away as Africa, where it damaged coastal villages despite beginning thousands of miles distant. This extraordinary reach makes tsunamis unique among natural disasters. They are truly global in scale. Communities that feel no shaking from the triggering quake may still face towering walls of water hours later. The ocean acts as the carrier, transmitting disaster across unimaginable distances. In their vast journeys, tsunamis remind us that Earth's oceans are one, boundless and connected, carrying both life and catastrophe from shore to shore. Firestorms can boil lakes dry. In the most intense fires, the heat released can reach unimaginable levels, capable of altering entire landscapes. Historical accounts from city firestorms, such as Dresden during World War II, describe lakes and ponds boiling away as the inferno raged. The temperatures inside a firestorm can exceed 2,000 degrees Fahrenheit, hot enough to vaporize water faster than it can be replenished. Witnesses spoke of fountains and reservoirs steaming, shrinking before their eyes. In wildfires, smaller ponds have been observed boiling or evaporating when surrounded by towering flames. These events illustrate the sheer energy contained in firestorms, not merely consuming wood and structures, but altering the very balance of water and land. To see a lake vanish into steam underlines fire's ultimate power. It is not just a force that burns, but one that can erase water itself, leaving only smoke and ash behind. Natural disasters can reshape entire civilizations in a single day. Throughout history, natural disasters have not only destroyed towns, but altered the course of nations. The eruption of Vesuvius buried Pompeii, preserving a city, but erasing its life. The Lisbon earthquake of 1755 devastated Portugal and reshaped European philosophy, inspiring debates about fate, science, and divine will. Floods along the Yellow River in China repeatedly redirected dynasties, while storms changed the outcomes of wars by scattering fleets. In modern times, hurricanes and tsunamis have toppled economies, reshaped migration, and redrawn coastlines. A single day of catastrophe can echo for centuries in politics, culture, and memory. These moments remind us that humanity, for all its power, remains intertwined with Earth's forces. Civilizations are built on landscapes that can shift in an instant, reminding us that history itself often bends beneath the weight of earthquakes, volcanoes, storms, and floods. And so, we have reached the quiet close of our journey, tracing these remarkable natural disasters, the great, restless forces of our world. We have wandered through earthquakes that make rivers flow backward, storms that carve coastlines anew, and volcanoes that paint the sky in strange colors. We have seen tsunamis racing faster than jets, avalanches burying valleys, and wildfires that carry their smoke into the stratosphere. Each story, in its own way, has been a reminder that the Earth is alive, always shifting, always remaking itself. Yet, as you rest here now, let these facts settle like soft dust after a storm. Nature's power can be fearsome, but in this space, it becomes something distant and almost dreamlike, a gentle hum in the background of time. The mountains, the oceans, the skies, and the forests will continue their long conversation, far beyond the span of any single lifetime. You are safe. You are here. The world outside will keep moving, reshaping, and renewing itself, as it always has. And you, for now, can simply let go. Breathe deeply, and imagine the steady rhythm of the earth beneath you, constant and enduring. Feel the weight of your body sink into rest, carried on the same timeless currents that shape rivers and carve valleys. When you are ready, allow your thoughts to drift like clouds over quiet landscapes. Let them grow softer, lighter, until they dissolve into sleep. And if you happen to still be awake, you can go ahead and watch the next video in the Sleepy Science series. But for now, may your night be calm, your rest be deep, and your dreams be touched by the quiet wonder of this ever-changing world. Good night.